Here is an extremely important question. From the given condition, you have to find the equation of the quadratic function. Question is, determine the equation of the parabola and explain if the equation is unique or not. Well, carefully go through the conditions and then write down the equation, possible equation for the parabola. At times, you can write more than one equation, right? And that's why the question is, explain if the equation is unique or not, right? Part 1 is, opens up with translation 4 units down and 7 units right. So find the equation for this kind of a parabola. Second one is passing through origin with x-intercepts at 5. Vertical stretch by a factor of 5 opens down, vertex at -3, 5. And the last one is passing through points 3, 5 and 5, 5 and range not more than 7. So these are the 4 conditions. You have to write 4 different equations. You can pause the video, write down your answer and then look into my suggestions. Now let's review. Question number 1. It says opens up with translation 4 units down and 7 units right. So whenever you have a parabola where transformation is given to you, best form of equation is the vertex form, right? So let's start with vertex form. It says opens up, that means A should be positive, then the parabola is opening up, and it is 4 units down and 7 units right. So we are assuming that the translation is from y equals to x square. 4 units down, that is the vertical, and 7 units right is the horizontal. So therefore, we can give an equation for this as y equals to a, where a is positive. Let me write a for the time being, okay? And then x minus 7 units to the right, right? When it is 7 units to the right, that means x minus 7 whole square, and 4 units down means -4, right? So that is the equation which represents this. Is it unique? That's the other part. Well, this one is not unique because a could be any positive number. So it is valid for all a's which are greater than 0. Right, so all will satisfy this particular condition. So it is not at all unique. So it's a family of parabolas which will have vertex at, you can say, 7 minus 4. Part B is, or question number 2 is, passing through origin and x-intercept at 5. Now, in a way, in this question, we are given 2 x-intercepts. One is at the origin, the other one is at 5. So that helps to write down the equation, and we can say the equation is y equals to a times, origin is x minus 0, just x. And the other one is at 5, so it is x minus 5. So that equation represents the given parabola. Here a can have all the values, right? So a belongs to real numbers, and of course a is not equal to 0 in either case, right? So that is kind of mandatory, right? Now a cannot be 0, but it could be any real number. Third is vertical stretch by a factor of 5 opens down, vertex is given to us at -3 and 5. So that becomes an equation which could be y equals to vertical stretch means just the term 5 opens down. When it is opening down, then it means it should be negative, right? So it is -5. Vertex is at -3 and 5. That means x and x value is -3. We'll write +3 here. So that gives me vertex at -3 whole square plus 5. So that becomes the equation, and this equation is unique, right? Right. The last one is passing through the points 3, 5 and 5, 5 and range not more than 7. Range not more than 7 means it is less than equal to 7. It's kind of like this, right? Where the vertex is at. So here, how do you find vertex? We are given 2 points here. The 2 points given to us are at 3, 5 and 5, 5. You'll notice that the y values are same, right? That means axis of symmetry should be in between. So axis of symmetry is at x equals to 4, right? Since these x values are 3 and 5, correct? So we know the vertex. Maximum is given to us as 7. It is at 4. Do you see that? And therefore, we know the vertex and we can therefore write down our equation. So, our equation should be y equals to a times x minus 4 whole square and plus 7, because it's not more than 7. So it is 7, right? Vertex is at 7. You can now find the value of a also. You can find the value of a by placing any one of these points. Now if we write 5 here, right, and then you can find the value of a, y is also 5. 5 minus 4 is 1, and you get 5 here. So we'll use this point 5, 5 to get the value. You get 5 equals to a times 5 minus 4 whole square plus 7. Now that means a is equals to 5 minus 7, which is minus 2, right? And therefore, we get our equation, and the equation should be y equals to minus 2 x minus 4 whole square plus 7. So that is how you can get the equation. Even otherwise, we could have got the equation. I will tell you how. The points are at 3 and 5, so this is at 4. So in the step of 1, you're going up by 2, right? So that is how you get 2, right? Since the parabola is opening downwards, we get the minus sign. So we could have got this value of a with logic also. But that's kind of a standard way of finding answer, and that is how you should be finding. I hope you understand with these 4 examples how to find equation of a quadratic function when we are given different kind of conditions. And you also understand in which conditions do we get unique solution and where we don't get unique solution. Well, if you can find the value of a, you get unique solution. If you can't, you don't get unique solution. So what we can summarize here is these two result into a family, right? So this is a family. And these two are distinct or unique, right? Since we can find the value of a. So it's kind of very important to understand this concept. I hope you appreciate it. Thank you.